Hey there, welcome back to the channel. We are just going to write an efficient reallocate this one. I hope we can complete it by this one because there's only, I guess, two more conditions remaining. So this is the condition where both the left and right blocks are not at all free. They're both allocated. So this one is when left is allocated, and we'll rearrange them in a better order afterwards. But for now, let's get started. This is the previous realloc. It doesn't do much. It just directly call my malloc and then copies the stuff and just calls my free, which is the free function. So we have to write a better one. So far what I've done is that if the size difference, if our block is shrinking, then we don't have to do anything much. We just have to check if the remaining size is at least header plus footer. What is this? Just consider for now that this is the minimum size. And if it's slightly greater than this, if the space left is not enough for header and footer, then we can't do much. It's fine. Just keep it. You know, it's a small internal fragmentation, but it's fine. Not a big deal. So let's just get into it. So this if condition checks that if our block is increasing and our left block is free, then what should we do? Well, if our left block is the only one which is free, so the thing is that here there will be a condition which is if right and those things are free. So there are going to be some stuff that I will add later on, but so far now, just let's get started. So this means that the left block that we are trying to, so the left block is free, basically means that. So here, if it's at least header and footer, then we can split the block. If it's not, then what should we do? Well, we have to change the, what you can say. Now that I think about it, hmm, now that I think about it, I think I have made a mistake. 2 minutes and 50 seconds in, and I have made a mistake. Boy, oh boy. Damn. Okay, so what I have in my mind, let me explain. So I have a whiteboard, let me explain. So let's say this is our allocated block, this one, and we have to change. Let's say the shrinking logic. Let's forget about the shrinking one. That is pretty easy. Let's say we want to increase the size. Let's say this is of 100 bytes, and I want sorry, and I want to make it 200 bytes. Well, what can I do? First, I need to check can if left and right both are free, can just the left one, well, I cannot just directly go for the left one. I have to go for the smaller one. So let's say this is 100 bytes and this is 200 bytes. Fine. And new size that we want is, let's say, 200 bytes. So I have to convert this 100 byte block into a 200 byte one. Well, one option is to merge these two if both of them are free. So I'll write over here, this is a free block and this is a free block. So if both of them are free, then we can go with either one. If we go with this one, then 100 plus 100 is 200. If we go with this one, then 100 plus 200 is 300, right? But which is more efficient? Which of the block that we go with will cause lesser fragmentation? It's definitely this one, right? but this will cause us to have a smaller block. So we should go with this bigger one. That's what I think. We should go with the bigger one so that the leftover block is a bigger block. So I have to check if left and right both are free, then which one. Okay, I have something in mind. Let's just start it. So first thing that I have is that if both of them are free, I should first check that all of them combined, can they be uh, at least of the required new size. If they are not, we can directly make a syscall to the OS and ask for a bigger block. Not, oh, I'm so sorry. Not syscall. We'll just call mymalloc function for a newer, bigger block. And if the block isn't present for mymalloc either, then mymalloc will call the SBRT, not the realloc. But yeah. So which one of these keys? Yeah, okay. I should write a better condition over here. So if if both of them are allocated, then no block found. Yeah, sure. And if both of them, if both of them are free, then we have to check what is the so first total size. Let's get the total size. So header block. Sorry. So wait, let me get the code from above. So it was present somewhere over here. Yeah, this one. Yank, boom, boom, boom. Yeah, okay. So current, left, right. Yeah, that's fine. We'll make a function instead. How about that? Yeah, let's make a function. No block found. Instead of no block found, it should be both allocated. Hmm. And then I will write another function which is both free. How about that? So both free will return a pointer to the space of the better block. So both free should take in the same thing, which is both allocated, pointer and line size. So void pointer and size, I guess. That's what happening, right? Yeah, okay. Cool. So now I will post that over here. Oh, cool. So I have current block. So the pointer that we are giving, that we have, is the space one. Pointer here is the space one, right? And the pointer that we passed to current BD, yeah, the pointer that we pass is the start of the space of the actual block. Yeah, yeah, cool, cool, cool. So this is cool. So now we have the values for current BD, the current block, left block, and right block. BD means block data, not anything fancy or anything. So let's compare. So also the required size that we want. Yeah, size is going to be the required size. Yeah, yeah, cool. So if let's get the total size. So total size is equal to well, left size plus current size plus left size plus right size, and also the header plus, well, two times the header plus two times. the footer, cool. And now if the total size when we merge all three blocks, is it satisfying the condition where it is greater than or equal to the size? Well, if it's greater than or equal to size, that's cool. And if it's not, that is a problem. We just return null. That's what we can do. Or we can ask, where's the function? Yeah, this is the function, right? Both allocated. Yeah, yeah. This is the function. Both allocated. Yeah. I should say new block. Copy block. Yeah, copy block sounds pretty good. So instead of both allocated, copy block. Cool. If yeah, void pointer copy block is equal to, well, not this, but copy block, the pointer that we got and the size. Cool. Sorry. Uh, so now, okay. So, well, no need for else, I guess. You can just do this. Yeah. So if the total size is greater than or equal to size, well, now we have to check which one is greater. So, yeah, right size plus left size. Yeah, let's compare. So, what is the compare function in C? So, compare function. What was the function in this? Instead of max in C. Whatever. What is the uh, in C? Compare in C language. Compare size T in C language. You don't have to write that one. Okay, fine, sure. Not a big deal. Uh, Size T, maximum size. It takes in two size T values, A and B. If A is greater than B, return A, return B. Cool. I should also write a minimum function. So size T, minimum size T A, size T B. If A is smaller than or equal to, then return A, return B. Okay, so size T max, I should call it max is equal to maximum size, left size, and right size. Cool. So now I will check. sorry. So size max. So this is the maximum size. So let's say right block. So now let's call it. Well, I can't see total size. Let's call it total size of one. I'll name something better, but right now just this is the thing that's coming in my mind. So total size one is max plus the current size. I should write that first. So the current size plus max plus a single header plus a single footer. Well, now that I think about it, we should get. Hmm. So the total size one, which is the only merging one of the blocks, if this is satisfied, so if total size one is greater than or equal to size, so total size one is greater than or equal to size, which we want, then it's cool. We can allocate it. If total size minus size is greater than or equal to header plus footer, then I will write another condition which is else total size 1 is greater than or equal to 0, and another else condition which is the total size is not greater than or equal to 0. In that case, we will end up merging with the smaller block too, which is like both the blocks. That's what we will go with. So yeah, merge both blocks. So cool. So total size 1 minus size header plus footer. If it's greater and it's at least header plus footer, which is the minimum, so we can split the block. So yeah, let's use a split block. So point pointer will return a split block, right? Point pointer split. Let's call it merge max. Void split is equal to, what should we call it? Um, what is the function? Split block. I forget the function. It takes in a block, it takes a line size, and it takes difference. Cool. Let's calculate difference beforehand. Size t difference is equal to total size 1 minus size. Cool. And boom, we have difference in our hand. So we have split block. First, we should pass it block, which is pointer. Yeah, got it. So you mean current block, current header. Yep. Hmm. So current header. So this is split block. Split block will get an align size and the difference. Cool. So it wants us to tell it how much size do we want. Well, it's definitely size. And what is the difference? This is the difference. Cool. Split block. Nice. And then we just simply return it. Return split. If the difference is greater than or equal to 0, well, in that case, it's greater than or equal to 0, right? Well, we got to make our own stuff. Yeah, we can return pointer, but we have to still construct the block. The block is still not constructed. So in that case, we should change the header and footer values. So if max is equal to, if max was meant to be by the left size, then we can change the values for the left header block. There should be a merge function, right? Sorry, it's nearly like it's 12:30, I guess. I'm feeling a bit sleepy. 24 minutes and we cannot make such a small video. Let's get going. So left size. So if max is equal left size, if max was found to be the actual left size, that means we need to merge the left size, left block and the current block. Okay, so let's write very bad code right now because I'm in no mood to make a better code. So left header left header size is equal to sorry left header size is equal to what do you say um uh, what total new size, right? Total size one. Yeah, and the footer will be current blocks. So current footer size is equal to same thing, total size one. And since it is allocated, we have to add or oops, or one. The same thing over here, or ones. And I guess that is it. I have to do a lot of changes. So yeah, the block is constructed, and now I need the space. So that will be the space for yeah space. So void pointer space is equal to cast into space char pointer. We get that from a left header plus header itself char moved by header. Yeah, cool. And then we return space. If this is found to be right, then right footer size is equal to total size 1 or 1 and current header size. We should also change the headers for this because it's not no longer a free block. So yeah, left header next is equal to null. Left header previous is equal to null. Current header size is equal to total size 1 or 1. Yep. And this will be an allocated block, but still, let's still do it. It's not current header. What am I doing? Current header next is equal to null, and current header previous is equal to null. Cool. And now else condition, which means merge both adjacent blocks. Ugh. Hmm. I'm so tired right now. Hmm. Wait. Even if we do find that left and right both are free, I'm making mistakes again. This should be like when we find that both of the allocated blocks are free, our first preference should always go to like, can I satisfy that using my own block? But that is already covered over here, right? Like the difference is greater than or equal to zero. So we know that the size is going to increase, and it's not going to increase by anything. uh, Sorry. Yeah, okay, so it's covered. No problem over here. So let's get. Oh, I'm so sleepy. I think this should be a great challenge. So like, uh, I can do a YouTube video like I don't sleep for 3 days and then I have to code something. That will be a very great form of torture. On top of that, I can do it in C++. I shouldn't be giving any person any kind of ideas. Sorry. So yeah, I guess it's perfect. I can't think right now. Oh boy. Mm, okay. So yeah. What was I thinking? I'm forgetting stuff. Okay. So first of all, we know that our current block cannot at all satisfy it. So we have ended up that we are going to merge the blocks. So here we check if the difference is at least header and footer. If it is, then we split the block. But what? Huh? Huh? What is happening? So wait, I should also have a check over here, right? I'm so sorry. So total size is greater than size. That's cool. So now my first preference should always be what? What was I thinking writing this code? Oh boy. Ah, if the difference is at least header plus footer, inside that there should be this condition. I think we should end the video. I can't think very clearly. Uh, it's also like it's going to be 1 o'clock, 1 a.m. I should sleep. 33 minutes. This might be the shortest video. So thanks for watching this video. I'm Altaba Charni and I'm an engineer for fun. Bye.